Hello everyone, this is a video that will take you through the probable questions on the Algebra I Regent. As I see it, I think every one of these questions has a good chance of being on there, so you should know how to do every single one of them. Right, as usual, we're just going to go through right now how to reset the calculator. It's the first thing that is being asked of you during just in the beginning of the test. The proctor is going to say reset the calculator. You press second function plus, then you go to 7, reset, and then it's on all RAM already. You press enter, and then you go to 2 for reset. RAM cleared. As soon as you do that, what I want you to do is to go to mode and go down to stat diagnostics. Once you're down at stat diagnostics, you are going to turn it on instead of off. All right. Once it's on, you press clear. You are ready to go, and you're ready for the Regents. Number 1, you will probably be asked to solve an equation. You can use substitution for a multiple choice question. Just remember that. But you must show all work for an open-ended question. Watch for distributing a negative. They will ask you to distribute a negative somewhere on the on this test, and you just have to watch for that. Just be careful. All right. So for number 1, like what I think is definitely going to be on there, something like this, where they have an equation that is set up like a proportion. So what do you do with a proportion? You just cross multiply. Remember, you have 3 times x plus 10, like that, and then 4 times 15, like that. Once you cross multiply, you set it up 3 times x plus 10. It's the whole thing. And then you just distribute like this. And it is 3x plus 30 equals 60. You subtract 30 on each side, just like that. And I'm going to go over here. You have 30 equals 3x, and you get x equals 10. Nice, easy question to start us off. A more difficult question, look on the June 2019. This is an open-ended question, so you have to show all of your. So just remember, when you go ahead and distribute, you see this is where the negative comes in play. That is negative 2/3 times x, negative 2/3 times 12. Use your calculator for negative 2/3 times 12. You see that's a negative 8. Bring everything else down. Then combine like terms. Do not move things across the equal sign until you combine like terms on each side. So we have negative 2/3 x minus 8 plus 2/3 x. These are the like terms. We're talking about this and this. So they cancel each other out. Look at this. Negative 8 equals negative 5 over 4x plus 2. Just going along and using inverse operations, we are just going to go ahead and subtract 2 on each side. You have negative 10 equals negative 5 over 4x. So you have a couple of things that you could do here. You can create a proportion by putting a 1 underneath the negative 10 and then cross multiplying, or you can multiply by the reciprocal. The reciprocal is when you flip the numerator and the denominator. So you have negative 4 over 5, the reciprocal of negative 5 over 4, and you have to do that on both sides. Once you have that on both sides, it will equal 8. You put it in the calculator, it will give you the answer just like this. Negative 4 over 5 times negative 10 is 8. All right, so that is an example of an open-ended question that you could possibly see. So it says the solution to this whole thing. So I'm just going to rewrite it. Always rewrite it, because you have you need some space to do this. All right. So you obviously, when you see those parentheses, you use distributive property. You have 3x minus 24 plus 4x equals 8x plus 4, just bringing everything else down. You have 3x plus 4x, combine like terms on that side. Don't start moving things across the equal sign yet. So we have 7x minus 24 equals 8x plus 4. Now you could start moving things across. Bring the smaller x over to the larger x. You don't have to, but we typically like to do that. It just makes things easier when you're solving inequalities, even though this is not an inequality. Then you subtract 4 on both sides, subtract 4 on both sides, and you get x equals negative 28. Right? So kind of like that, you should be able to do rather easily. Again, you could substitute in if you would like. It's up to you. For this one, this is another difficult question, a little bit more difficult than this one is, or this one was. So this is from the January 2020 Regent. And I'm just going to rewrite everything over here. And the first thing that you do is subtract that 2/3. You want to get rid of the 2/3. You want to put that on the other side of that equal sign. And then once you go ahead and you're confident, you could just rewrite whatever's left on the left side and then equals. And then you're going to take your calculator and do 17 over 12 minus 2 over 3. And that is 3/4. So 17 over 12 minus 2 over 3 is 3/4. Again, we have a proportion. So we're going to do the cross multiplication. So this is 4 times the whole thing, x minus 3. So we're going to put that in parentheses. And then 4 times 3 is 12. Then we do distributive property. You get 4x minus 12 equals 12. And you add 12 to both sides. This is 4x equals 24. And you will get 6. X equals 6. And you go back up, circle 6, that is 2. So these are the types of situations where you have to be able to solve that equation. You'll probably be asked to solve an inequality. All right, so just be ready to solve one inequality that is not in or out of the solution set. Remember, that is in or not in the solution set. Remember, when dividing or multiplying by a negative, you must flip the inequality. Very, very important. So we're going to just go ahead and distribute. Just like that. And then we have 8y and then plus 4. Bring the smaller y over, smaller coefficient over. So we have negative 12. You do not have to flip the inequality symbol for y. That is a positive. And then plus 4, you minus 4 on both sides. This is an open-ended question, so you do have to show all of this work. Again, you're not flipping the inequality. You're dividing by a positive. You're not flipping the inequality. And we are going to get negative 4. So y is greater than or equal to negative 4. That is the answer. Open-ended. So this is given the 7x plus 2 is greater than or equal to 58. This was on the January 2020 Regent. This was number 3, which number is not in the solution set. So the first thing that you have to do is that you should solve. You can substitute in and see which one is not in the solution set, but I kind of like to solve it, and this one's pretty easy to solve. So you have 56, right? And then you divide by 7 on both sides. You need 8. So if you're reading this, you have to be careful. Don't circle 8, right? Which number is not in the solution set? X is greater than or equal to 8. Which one's not in the solution set? 6 is the only one that is not in the solution set. Be careful. All right, so number 3. You'll probably be asked to translate an inequality from a real-world situation. So let me read this to you. This is on the June 19, 2019, number 10 Regent. Number 10 question. So David wanted to go to an amusement park. A sign posted at the entrance say you must be greater than 42 inches tall, and no more than 57 inches tall for this ride. So this right here, this is a compound inequality. You have to know how to read them from the middle out to the number on the left and the middle out to the number on the right. So this says x is greater than 42. This says x is less than 42. I'm going to cancel that out because you have to be greater than 42. X is greater than 42. X is less than 42. 4 is out. You only left with 2. So the other one, no more than 57 inches. No more than 57 inches. X is greater than 42. And X is less than or equal to 57. Oh, okay. So X is greater than 42. Or X is less than or equal to 57. So tricky question. Is it an or an and? It's an and because you can be greater than 42 and it says and no more than 42 inches. So you have to pick this. You cannot pick anything with or. I should have canceled out 3 right off the bat. I didn't. From the August 2018 Regent, this is number 10. Gretchen has $50 she can spend at the fair. Ride tickets cost $1.25 each. Game tickets cost $2. She has $50. She wants to go on a minimum of 10 rides and play at least 12 games. Which system of inequalities represents this situation where R is the number of ride tickets purchased and G is the number of game tickets purchased? So let's just talk about this. She has $50. So it's not less than 50. It's less than or equal to 50. So let's just talk about the ride tickets. So the ride tickets are $1.25 and the game tickets are $2. So I like this inequality, right? But it's not less than 50. She has less than 50. She has 50. So the only thing I don't like about this inequality is the less than symbol. So it has to be less than or equal to, right? Because it could be equal. She spends all her money. It's equal to. So I'm going to cancel out 4 as well. So then I have $1.25R plus 2G is less than or equal to 50 for this one. And I have this for this one. So she wants to go on a minimum of 10 rides. So 10 or greater. And then she wants to play at least 12 games, 12 or greater. So, 2 is your answer. All right, because it's greater than or equal to. It is not just greater than 12. She wants to play more than 12 games. She wants to play at least 12, 12 and more. All right, so 2 would be your answer for that one. All right, on this one, this is the 4th type of problem that you'll see. You'll probably asked to calculate the output of a function when provided this input. Remember, you could do this on the graphing calculator. You could just do it on the graphing calculator, but I'll show you how to do it by hand. This right here, anything inside parentheses, they want you to use as the x. They want you to substitute that into this right here. So it comes out to be k of x, which now the x they're telling you is -3. So you write it that way. And then -3 goes in for the x in parentheses squared. The squared on the outside. You have 5 times the -3 plus 3. That's the way to do it. And if you put this directly into the calculator, which you could take right now, right into the calculator, you get 36, you're done. Right? Another way to do this is what I'm going to show you right here. You press the y equals, you put this whole thing into the calculator. This is your y, right? So if we have 2x squared minus 5x plus 3. That's all you have to do. Press second function, table. You don't care about what the graph looks like. They want the x as -3. You just go up to -3. There's the 36. That's your answer. Plain as day, simple as that. All right. So we'll do it again, and I'm going to do this real quick. So you have 4x. Put this in y equals 4x plus 5. Then I'm pressing second function table, and I want a value of this x is -3. I go up to -3. It's -7. Done. All right. You could substitute in if you really want. It's like this. And if for an open-ended question, you have to show that. But I like to put it into the calculator and have the calculator give me the answer. And that is basically it. Number 5, you'll probably be asked to simplify an expression. Just remember that you will be asked to distribute a negative. So we're going to have distributive property here. We're going to go 3x plus 12, and we're going to distribute this negative. Remember, when you distribute a negative, you will make everything inside that second set of parentheses the opposite sign. You will negate everything inside that parentheses. This was a positive 2x, now it becomes a negative. This was a positive 7, now it becomes a negative. Now all you have to do is combine like terms. 3x minus 2x is x, and then 12 minus 7 is a plus 5. You have 1 as your answer. That cannot be any easier. All right, which expression is equivalent to this? Again, all you have to do is distributive property. So 2 times x squared is 2x squared. 2 times -1 is -2 plus, and then you're going to distribute again, which is 3x squared. 3x times x is 3x squared. 3x times -4 is -12x. So we have 2x squared plus 3x squared. That's 5x squared. 5x squared, 5x squared, 5x squared, 5x squared. So we could cancel those out just to get them out of the way. Minus 12x, 12x. Minus 12x, minus 12x. So these are out. So that's out. Minus 2. This is your answer. All right, just be careful. You could also put this in as y1, the entire thing. And you could put these in as y2, see if they match. All right, just a little tricks that you could use your calculator, even if you don't know what you are doing. All right, as far as the distributing goes. You'll probably be asked to factor a quadratic. Just remember, this is a factoring, like, these are factoring questions. They are going, this is an algebra test. You're going to have to factor. All right, so the easiest way to do this when you have a multiple choice going is to distribute, right? So I'm going to just go ahead and say, all right, -27. It has to be positive times a negative to equal that last number, right? As a negative. It has to be positive, negative. If it's positive, positive, it's no good. I can't cancel any of them out because they're all positive, negative. So let's go over to the number 3, let's say. And I'm just going to do distributive property foiling, if you want to say, just on this and see if it kind of works out to this. So 4x times x is 4x squared. 4x times -3 is -12x. And 9 times x is positive 9x. 9 times -3 is -27. That works out. 4x squared minus 3x. You're combining like terms here. And minus 27. That works out. 3 is your answer. I picked the right answer. If you did something over here, it wouldn't add up. It wouldn't multiply to this. All right. So for June 2019, they asked this question. Does it look familiar? Yes, it does. They repeat questions. So go ahead and factor. I'm going to start with number 3 again. Well, let's see. I have -3 here. Look, it's plus minus, plus minus, plus minus, plus minus. Didn't give me any inch here to work with. But I'm going to start with number 3. 4w times w is 4w squared. 4w times -3 is -12w. And then positive 1w. And then 1 times -3 is -3. I did it again. Pick the right answer. And it's -11w when you combine these like terms. And it's -3. That's not a plus. That's a minus. So this is your answer, number 3. Which expression is equivalent to 18x squared minus 50? So this one is a little bit tricky. I'm not going to say it's not, but just look at your multiple choices. All right, look at them. What are they factoring out of each one? Factoring a 2. So factor a 2, right? So even if you don't know what to do, we're going to factor a 2. I'm just going to say 18x squared minus 50. I'm going to rewrite it. And I'm going to factor a 2 out because that's what they did, right? 2 goes into 18 9 times. So I'm going to factor that out. 2 times 9 is 18, and then the x squared stays in there. 2 goes into 50 how many times? 25. I do not know what this is, right? But remember, this right here in parentheses is the factor of perfect squares, factor of squares. So we have 2 on the outside, and we're going to put this as the factor of squares. We're going to put 3x times 3x, because that's 9x squared. And what times what equals 25? Plus 5? Minus 5. So this is your answer. Like that. All right, listen. If you don't know how to do this, here's a little bit of a trick. Do you see that I put 18x squared minus 50 into the graphing calculator? You see what the graph looks like? All right, here we go. Now, do you see that on y2, I just put this in as y2? So now I'm going to press graph. It's the same graph. That's the expression that's equivalent. So if you put the other ones in, it will not be equivalent. If you don't believe me, look at the table of the graphs. All right? They are exactly equal. So that's how you can do the problem without actually factoring it. So if you don't know how to do the problem, grab your calculator and put whatever the expression's in. All right, put them in. See which one is equivalent. All equivalent expressions are the same graph. Take a look at them. They're the same exact graph. Now, I don't want you to get confused with this question, but it's an easy question. It's not that bad. Look, it says it's solve for the exact values of x. So just go ahead and do that. You know how to solve for x, right? You add 42 on both sides. You have to get the x alone. So you have 6x squared equals 42. And then you divide by 6. And x equals 7. And you add the opposite inverse operation of squared is square root. So you square root both sides, and you get x equals plus or minus square root of 7. You stop there. You want the exact values of x. There they are right there. All right, number 7, you'll probably be asked to determine if a relation is a function or not a function. The relation can be given in coordinate pairs, a graph on a coordinate grid, an equation on a map and diagram. Remember, every x value must have its own y value to be a function. If any x value repeats 99.9% of the time, it's going to a different y. And that means it's not a function. So it's just pretty simple. The June 21 Regents, number 4, perfect question. Which relation is not a function? So that means they're looking for the one that's not a function. This one is a function because every x has its own y. This one is a function because the x's don't repeat. Every x has its own y. Number 2 is a function. Every x has its own y. Do you see 6? 6 goes to 10. 6 also goes to 12. 6 is repeating. The x is repeating, going to 2 different y's. Not a function. 4 is your answer. Which relation is not a function? Let's go over the x's. Are the x's repeating here? That's a function. Are the x's repeating here? 2 is repeating. It's going to A and it's going to B. You only choose one. Every x must have one y attached. 4 is your answer. By the way, the vertical line test will tell if any graph is a function or not. If it goes through once, that means the x is not repeating. If it goes through twice, one or more, if it goes through twice, that means the x is repeating at that moment and it is not a function. You would have to solve this one for y. We're not doing that right now. All right, number 4 is the answer. Number 8, you'll probably be asked if the operation of expressions will be rational or irrational. All right, if they put this question on there, just grab your calculator and figure it out. Right? So explain why. This is open-ended. So that means you have to write down what is going on here. So explain why A plus B is irrational, but B plus C is rational. So really, I start off with just putting A plus B down. A is square root of 20 plus 2.5, so that's B is 2.5. 2.5 is a rational number. It is, if you want to put that this is rational, because that is a terminating decimal. All right, terminating decimals are rational. Square root of 20 is a non-perfect square, which is irrational. All right, so an irrational plus a rational equals irrational. B plus C, 2.5, again, is a terminating decimal, so that is rational. Square root of 225, so this is rational, plus a perfect square. Perfect squares are rational. Rational plus rational equals rational. Done. All right, is this product square root of 16 and 4/7 rational or irrational? So, square root of 16 is 4. It is a perfect square. Perfect squares are rational. 4/7, all fractions. Rational. So that means if you're multiplying them together, rational times a rational equals rational. You will get credit. See what I put in my calculator. I got square root of 16 times 4/7. It comes out to 16/7. It's a rational number because it is a fraction, right? So you will get credit for saying that this is rational. This product is rational. That is the answer. So you could say square root of 16 times the times 4/7 is rational because it equals a 16/7. 16/7 is a fraction. You're good to go. Which expression results in a rational number? You would take the square root of 2 and then make sure that you press to the right to get away from that, and then the square root of 18. And you can press enter right there. It is 6. Which one results in a rational number? This is rational. 1 is my answer. All right, make sure that you're ready to answer those. Use your calculator at every step. Right? So number 9, you'll probably be asked to what the transformation from a parent function will be compared to another function. It doesn't have to be a parent function either. They could ask you from one function to another. You just graph both of them into your calculator and just remember to use your calculator. So for this one is a little bit tricky. All right, it says the parent function of f of x is p of x equals x squared, which is right here. So I put that in as y1. The graph of the function, this right here, where k has to be greater than 0, would be a shift of. They want to know what the shift is from the parent function. So if they're asking you what the shift is, you see this k? They're not telling you what k is, but they're telling you that k is greater than 0. So I just picked a number, 2, right? So if k is 2, I'm going to press my graph right now, and I just made up 2. It goes to the right and then up. So it doesn't go left. Doesn't go left. Goes to the right and up. To the right and down? No. 3 is your answer. That's basically it. Use your calculator. Same thing with this one. And you just put them directly in. Now, this is not a parent function, so we're just going to go comparing two functions to f of x and g of x. I have them both into my calculator, and you see the first one is the blue one. So the blue one is the f of x. The red one is the g of x. What happens from f of x to g of x? It goes to the right, 3, and shifts to the right, 3. And that's it. Right? Use your calculator. Number 10, you'll probably ask questions about domain and range. Remember, domain is the x and range is the y. Remember, domain is the list of x and range is the y. Which domain would be appropriate for the function that compares the number of emails sent to the amount of data that the cell phone uses? So, would it be integers? No, because negative emails sent? No. Rational numbers could be terminating decimals. Irrationals, no. Whole numbers would be most appropriate. 1, 2, 3, 4, 5, 6. So the function of f of x, this is January 2019, is this, and has a domain consisting from -2 to 1 inclusive, which set represents the corresponding ranges for those domains. Grab your calculator, put this in, f of x, there it is, I put it in. There, it says it has to have a domain that is consisting of integers between -2 and 1. So I am going to press second function table and go to -2. And here's to 1. What are the corresponding ranges for those domains? So it's -16. Then -1 is also -16. Then 0 is -12. And 1 is -4. So we have -16, -12, -4. 2 is my answer. I don't have -32, so that's out. That's out. -16 and -4. -12 is missing, so that is out as well. 2 is my answer. Make sure you use your calculator. You'll probably be asked if a function is linear or not linear, or exponential or not, right? Which situation is not a linear function? Remember, a linear function has a steady rate and a constant rate. Not steady, constant, right? It is steady, but constant rate. It has to be the same amount increasing or decreasing each time. So anything that changes, that's exponential, right? So a gym charges a membership of $10 down and $10 per month. Okay. Not a linear function. 10 down, $10 per month. Another $10 per month. Another $10 per month. This is steady. This is linear. They're looking for one that's not linear. A cab company charges $2.50 initially and then $3 per mile. The first mile, $3. The second mile, $3. The fourth mile, $3. Every mile, $3. That is linear. It's a constant rate. Restaurant employee earns $12.50 per hour. The first hour, $12.50. The second hour, $12.50. Third hour, it's not changing. That's out. Linear. A car that is $12,000 depreciates 15% a year. 15% of $12,000 the first year. Then it minuses from that amount, and then another 15% of a different amount. This is not linear, so that is not a constant rate. So for this one, June 2019, they switched it up a little bit. Which one can be modeled by a linear function? The population of bacteria triples every day. No, if it triples every day, it starts at a number and it triples, then it goes to that number and triples again. That's not a constant rate. That's not linear. The value of a cell phone depreciates at 3.5%. No, not linear. Amusement park allows 50 people to enter every 30 minutes. Okay, 50 people, a half hour. The other half hours, 50 people. This is a constant rate. That is linear. Basketball tournament eliminating half of the teams. That is non-linear. All right, number 12, you'll probably be asked to identify what property is being used. So we're going to take a look and just always do what is happening here. So when solving this, Kate wrote this. So what did she do? What did Kate do? It looked like she added 7 on both sides. Because look, it's p squared now. This cancels. Plus 12. So 5 plus 7. So that's what she did. She added 7. Is that associative property, commutative property, distributive property? It's not distributive property unless you see parentheses. Addition property of equality means that you're adding 7 to both sides of the equation. That's it. The addition property. August 2017, number 1. First question on the test. Part of Jennifer's work to solve this equation is shown below. This is the given. Here's the step 1. So what did she do? It looked like she did just that. What property is that? Distributive property of multiplication of a subtraction. Then this was an open-ended question in January 2020. A little bit confusing, but this is the given right here. And then something happens and they want you to state a property of numbers for each missing reason. So just look. Okay. So this is what happens. They do distributive property here. They do distributive property here. So what do you think it is to get to that? It is distributive property. All right. So the next thing that happens is combining like terms. That's exactly what they did. So they get to this, they combine like terms, and they have 8a plus 12 equals 34 minus 14a. Then what do they do? Okay, so the 34 is here, the 12 is here. Wait a minute. They get the a's together. And it becomes 22a. Adding something on the same side, on opposite sides, adding that same thing on opposite sides, what property is that? It is the addition property of equality where you add the same thing on both sides. Look, they asked it in 2019. They asked it again in 2020. Addition property of equality. If you subtract it on both sides, it would be the subtraction property of equality. If you divide it on both sides, it would be division property of equality. Number 13, you will be probably asked to find the zeros of each function. So the zeros is where the polynomial crosses the x-axis. So just remember, all they're asking you is for the x-intercept. Sorry, I made that a little bit messed up there. All right, so they're asking for the x-intercept. But there's a really easy way to do this by hand. The zeros right here is -3, 0, and 4. So just take a look. I like starting with number 3. I don't know if that's the answer. But x, you have to set each one of these equal to 0. Right? That's how to do it. All right? So x itself equals 0. Do we have that? Yes, we do. Then x plus 3 equals 0. Minus 3, minus 3. X equals negative 3. Do we have that? Yes, we do. Then x minus 4 equals 0. Plus 4 plus 4. X equals 4. Do we have that? Yes, we do. This is the answer. And that's all you have to do. But if you don't know what to do, always go back to the calculator. The calculator will tell you where it crosses. I already put this in. This is choice 3. See that? I put that into the calculator. Once I put that into the calculator, I'm going to press graph. This is negative 3. Negative 3. 0. And here is 1, 2, 3, 4. 4. You could tell on the calculator that this polynomial crosses at these zeros. You just have to know what the zeros are. You really don't need to do anything except for put it in the calculator, all right, and just read the calculator. So this is, you probably be asked the most appropriate type of number to use in a situation. Which domain would be most appropriate for the function that compares the number of emails sent to the cell phone plan? We did this one already. But this is the June 2021. It repeats. So obviously email sent amount, we said it was whole numbers. So right there. August 2019, number 21, dolphin jumps out of the water and back in the water. The jump could be graphed on a set of axes where x represents time and y represents the distance above or below sea level. The domain, the x value, right? So the x right here represents time. So integers only for time, positive integers, real numbers, or positive real numbers? What do you think? Remember, time is continuous. So we're gonna say it is not just real numbers, because you have to, time is continuous, but it's also positive. So it can't be all real numbers, because that would include negatives. All right, so just remember, integers includes negatives as well, and time could be in between. Like, it's not just an integer like 1, 2, 3, 4, 5. So it has to be all positive real numbers, and that is basically it. Number 15, you'll probably be asked about a question of which system has the same solution. So just bear with me here. You have to go ahead and see if you could solve this, right? So we're just going to go ahead and rewrite it like this. I'll multiply this bottom one by 4 because we want to get one of the variables to cancel out. If this is 4y, it will cancel out with the negative 4y. Just remember, you have to distribute through the whole thing, right? For that whole equation. So I'm just going to write x minus 4y equals negative 10. And let's see if I could get this canceling out. The 4x plus the x is 5x equals 10. And then 5 divided by 5, x equals 2. Now I'm just going to substitute this 2 into the original, this equation, because it's easier. So we have 2 as the x right here, plus y equals 5. You minus 2 on both sides, and you get y equals 3. So 2 and 3, x equals 2, y equals 3. So I'm just going to go over here. I like starting with 3. 2 plus 3 equals 5. That works. 2 plus 3 equals 5. That works. 2 plus 3 equals 5. That works. Now I'm going to go to this one. Negative 3 times x, which is 2, equals negative 30. Is that true? No, it's not. Not close. Let's go to this one. 5 times 2, because my x is 2, equals 10. Yes, that works. 1 is my answer. I'm going to do the same thing here. So we have, I'm going to multiply this by 2. So I'm going to get 2x. I'm distributing here, just so, like, I know a lot of people have confusion about this. Plus 6y equals to 20. Remember to distribute all the way. So then this is negative 2x. I'm just rewriting the second equation down, equals 4. This cancels. This is 4y. I'm just going to write it here. 4y equals 24. 20 plus 4. Then you divide by 4, and you get y equals 6. Y equals 6. I'm going to go up to this first one here and say x plus 3 times 6, because y is 6, equals 10. So I get x plus 18 equals 10. And then minus 18 on both sides equals negative 8. X equals negative 8. I'm going to start with 3. Negative 8 plus 6 does not equal 6. That's out. Negative 8 plus 6. Does that equal 14? That's out. Negative x. All right, let me start with 1. Negative x. If x is already negative 8, that means they want me to substitute an 8 in. Plus y, which is 6. Does that equal 6? No. 8 plus 6 equals 14. This works. 2 is your answer. I don't even care about the second one, but it does work. All right. That's how you do that. Really difficult pattern questions, but it's not really that bad. All right. Given the pattern below, which recursive formula, out. Here we go. So this is 3. I'm counting the triangles. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 9. Okay. So you see this a sub 1? This is a sub 1. Does it start with a 2 or a 3? 4 is my answer. This right here is always the prior term. So a lot of people don't know. All right, so what are they talking about here? You see this a sub n? That's always what you're looking for, right? So a sub n is, we're going to look for a sub 2. So do you see how I'm putting 2 in for the n? So that means I have to put the 2 in for this n as well. A sub 2 minus 1. A sub 2 minus 1 plus 2. A sub 2 minus 1 is 1. A sub 2 equals A sub 1. This is A sub 1 plus 2. A sub 1 is 3. So we write it A sub 2 equals 3 plus 2. A sub 2 equals 5. Right? And you just go along like that. All right? Remember, the n minus 1 is the prior term. All right, so if figure 1 represents the first term and the pattern continues, how many shaded blocks will there be in figure 35? Okay, so we have the shaded boxes. I counted each shaded box. This is 12, this is 16, this is 20. It increases by 4. All right, so you go onto your reference sheet, and they do have this formula there on the reference sheet. So now, like, a sub n is the term that you're looking for, right? So I left it blank here. 12 is the first, it's a sub 1. So this is your a sub 1, right? And then n minus 1, you just put down the term you're looking for minus 1, right? And then the difference, the common difference is the 4, right? Because it's increasing by 4. So if we're looking for figure 35, you're going to put a sub 35 equals 12 plus 35, because we're looking for 35, which is the n, minus 1 times 4, because that's the common difference. Grab your calculator, put it in, you get 148, and that's what it is. All right, tough question, but that's how you do it. Number 17, you'll probably be asked to identify a leading coefficient next to the variable with the greatest exponent. Remember, the leading coefficient is next to the variable with the greatest exponent and a constant without the variable. All right, so standard form is arranged from largest to smallest exponent, like this example here, negative 5x to the third plus 6x squared minus 2x plus 5. This is the constant. This is the leading coefficient. So students were asked to write the expressions with the leading coefficient of 3. Leading coefficient of 3. This is the leading coefficient right here, because C has the x to the third. That's not 3. Leading coefficient of 3. That is not 3. That's negative 3. That's out. Leading coefficient of 3. Leading coefficient of 3. Okay. And a constant of negative 4. Constant of negative 4. Constant of positive 4. This is the answer. August 2019. When x times x minus 5 times x 2x plus 3 is expressed as a polynomial in standard form, which statement about the resulting polynomial is true? They have constant term is 2, leading coefficient is 2. We have to multiply. So let's go ahead and take the binomials first. We have x minus 5. We have 2x plus 3. X times 2x is 2x squared. X times 3 is 3x. Negative 5 times 2x is negative 10x. Negative 5 times 3 is negative 15. I remember, I'm going to combine like terms right here, but remember I have this x out here. So I have 2x squared, and then positive 3 and negative 10 is negative 7x minus 15. And all that is going to be multiplied by this x. So let's go ahead to distributive property. We have 2x to the third. X times 2x squared is 2x to the third. X times negative 7x is negative 7x squared. And x times negative 15 is negative 15x. All right, constant term is 2. Nope. There is no constant curve. Leading coefficient is 2. Yes. The degree is 2. No, it's 3. The number of terms is 2. No, there's 3. 2 is your answer. All right, be careful with those. Be careful. All right, number 18, you may be asked a statistics question based on a two-way table. Remember, to calculate a percentage, you must create a fraction. So fractions are always part over whole. In other words, the bottom number, the denominator, must be the larger number. All right, so Gianna took a survey of her senior class to see whether they preferred pizza or burgers. Oh, that's a tough one. The results are summarized in the table below. So we have male, female, pizza, burgers, who cares? All right, of the people who preferred burgers. So that means we have to add the burgers up. All the people that preferred burgers. So approximately what percentage were female? So let's go ahead and do 42 plus 26. That's 68. So of the people who preferred burgers, 68. How many were female? Female, 26 of them. You grab your calculator. 26 over 68. 26 divided by 68. That is 0.382. Approximately. 2 places over to the right. That's this. 2 is your answer. And that is everything. So a survey was given to 12th grade students. high school, blah, blah, determine the senior class trip. Results are shown to the nearest percent. What percentage of the boys chose Niagara Falls? So the boys. So we're going to have to add 56 plus 74 plus 103. And so we added all the boys. There were 233 of them. And then how many boys chose Niagara Falls? Niagara Falls, 56. I created my fraction, 56 over 233. I put it in my calculator. I got 0.240. It says round to the nearest percent. That is going to stay 24%. It is 2. All right, just remember, any statistics problem like this, you are going to be asked to round and to create a fraction, and the fraction goes to a percent. Using the method of completing the square, determine the exact values for the equation. Completing the square, just remember, I'm just going to rewrite this right here like this. And completing the square, you must get the constant away from the numbers with the variables. So it's like this. Then you take the -8, which is the b value, and divide it by 2. And then you get your answer, -4. Then you square that. You're completing the square, and it is 16. You go back to this, which is x squared minus 8x, and you add 16. You're completing the square, -6 plus 16. Or you add 16, you add your value to both sides. So now you're going to factor this. And what's going to happen is that, let me get that out of there because that looks really bad. What's going to happen is that you are going to have x and x. This is going to be, do you see this answer right here, this -4? It is going to be x minus 4 and x minus 4. The reason why is because -4 times -4 equals positive 16, and -4 plus -4 equals -8. And this becomes 10. So when you rewrite this, this is x minus 4 squared equals 10. We're figuring the exact values of x, so that means you have to solve for x. So the opposite of squared is square root. So we're going to square root both sides, and we're going to have x minus 4 equals plus or minus the square root of 10. Since we're looking for exact values, I am not solved for x yet, so I'm going to rewrite this as two separate equations. I'm going to write x minus 4 equals square root of 10, and I'm going to write x minus 4 equals the negative square root of 10. You add 4 to both sides. This cancels. X equals 4 plus square root of 10. And I'm going to put x equals, this cancels, 4 minus square root of 10. These are the two values, this answer and this answer. Completing the square. All right, so completing the square, determine the vertex. This might be a different type of problem here. So we're going to do the same thing. We're going to put x squared minus 14x minus 15, and that all equals 0. All right, this is kind of like the 0, the y, whatever. To complete the square, you have to add 15 on both sides. This cancels. You have x squared minus 14x equals 15. And then you take negative 14 divided by 2. B, the b, negative 7. Then you take negative 7, square it. You get 49. You're completing the square. Then you're going to take x squared minus 14x. You add 49 to that, to the left side. And then you take 15. You have 15 here. You see that? And then you add 49 to the right side. Remember, this is going to be factored You're looking for a number that multiplies together with another number that equals 49, perfect square. So it's 7 times 7. But it's not just 7 times 7. It's -7 times -7. And the reason why this is because it has to add to a -14x. All right? So you go ahead and you put x minus 7 squared, because that happens twice, equals 64. We are not going to solve because we're determining the vertex. And the vertex is that amount, like it's either minimum or the maximum. All right, the highest point or the lowest point. So we're not going to solve it. We're going to get it in vertex form. So vertex form, we're going to have to subtract the 64 on both sides. And it is now x minus 7 squared minus 64 equals, like, you could put f of x or whatever, 0. So now the vertex is the number inside the parentheses, the opposite of that. So it's, see how it's a -7? It is 7. And then you see this -64, that stays the same. That is the vertex. You could always put just to check it, you could always put this into the calculator and see the vertex. We're just not going to do that now. All right, we just don't have the time to do it now. Number 20, you'll probably be asked to solve a literal equation. So it says solve the formula for f. Solve this formula for f. So I'm just going to rewrite it. I like it, you know, I like the formula to be a little bit larger than what they write, the printing that is there. It is not good enough. Please do not ever distribute here because you're looking to solve for what is inside the parentheses. If you distribute, you're making a mess out of everything. So we're not going to distribute. We want to get rid of the 5/9. How do we do that? We're going to multiply by the reciprocal. So we're going to multiply by 9/5. 5/9 and 9/5 are reciprocals of each other. They cancel. They cancel. And then you have 9c/5 on this side equals f minus 32. You add 32 to both sides. This cancels. You have 9c/5 plus 32 equals f, and you are finished. Solved for f. All right, just remember, don't ask yourself what you want to get rid of. Most of the time, it's going to be something that you that is a fraction that you want to get rid of. Do not distribute. Do not distribute when you're solving a literal equation. All right, and that's it. All right, so number 21, you'll probably be asked to solve or state a linear regression equation based on a set of data. Remember, when you reset your calculator, stat diagnostics is automatically switched off. Do you remember when we, in the beginning of this video, we reset the calculator, and then all of a sudden the stat diagnostics, we went to mode and we turned it on? Well, that's for this question. The easiest way is to press mode and then stat diagnostics from the list. You turn it on, and then that's it. So for a question like this, it's asking for state the linear regression equation. That is basically what you need that stat diagnostics to be on for. This is going to be your first list. This is going to be your second list. All right, so we're going to grab the calculator. I'm going to show you exactly how to do that. Your stat diagnostics is on already. All right, you see it's on. And then you're going to press stat. So if you press stat right now, let me make this a little bit bigger. All right, and you're going to press, and it's on edit. You're going to go to edit, and you see this L1? We're going to put all of the numbers from L1. You see that where that X is right there? I'm going to move this up just a little bit. See this 0? I'm going to press 0, and I'm going to press enter, and it goes into the list. And see 10, enter, 15, enter, 20, enter, and 30. Then I'm going to go over to L2. I'll move this over here. Make this a little larger. All right, and we're going to start 68, enter, 84, enter, 104, enter, 100, enter, and 120. And enter. Enter. All right. So it wants the linear regression equation. So press stat. We are on the edit thing. If you press enter again, you'll go back to the list. So you want to press stat and you want to move it over to calc. And we want to go down to linear regression. See this ax plus b? That's where you want to go. You want to press number 4. And we have L1, L2, you press enter again, you press enter again, you press enter again for calculate, and you get your linear regression equation. So the A is your slope. Your B is your y-intercept. So it is y equals 1.72x plus 69.4. That is the linear regression equation for this set of data. All right, we're going to press, is that it? Okay, yes, that is it. All right, going crazy here. Number 22, you'll probably be asked to calculate correlation coefficient on a set of data. This is different. Correlation coefficient is the R. All right, so just remember, stat diagnostics is on. Just leave it there. Correlation coefficient is the R. After pressing stat, and then you press 4 again to get this. Do you see this graphic here that I put? This is how you're going to explain what the correlation coefficient is, because always they ask the correlation coefficient and then they ask a backup question like this. Explain what the correlation coefficient means to in the suggest in the context of the problem. So we have the jumping jacks from this. This is the same one. So we're just going to go to the table again right here, and we're going to lift up this and go back to the table. I'm going to show you that this table matches this table right here. All right, so it matches the same. It's the same table. So we have the input in, and it says state the correlation coefficient. So now we're going to round it to the nearest hundredth. We're going to press stat, and we're going to go over to calc again, and we're going to press 4 again, just for the linear, like the one that we had before, the linear regression equation. We're going to press enter like 4 or 5 times, and you see the R? That's what you need. Here's the linear regression. I'm sorry, here's the correlation coefficient, right? So the correlation coefficient is 0.967. All right, I'm going to write that down. 0.967. 0.967. So it says round to the nearest hundredth. So I'm going to round it to R equals 0.97. And that is rounded to the nearest hundredth. Now, if you take a look at this chart here, anything that is close to 1, right, which is 0.97, is very close to 1, is a very strong positive, and you have to state it that way. Anything close to -1 is a very strong negative. All right? They usually ask either very strong positive or very strong negative, or sometimes a weak negative, like if it's close to 0. But this one is 0.97. So in the next question says, explain what the correlation coefficient is suggested in the context of this problem. So this is exactly what you put. The correlation coefficient of 0.97 suggests a very strong positive correlation between the number of jumping jacks and the heart rate. You realize that I'm getting these words very strong positive, like it's close to 1. So it's a very strong positive. Correlation, I use the word right here, correlation between number of jumping jacks, this is where I'm getting it from, and heart rate. So I'm not making up the words, I'm using the words that they're giving me, and that they're providing in the question. All right, number 23, you'll probably be asked to solve for the exact values of x using quadratic formula. Remember, look up the formula on the reference sheet, copy it down. I do not have this memorized. You should not have it memorized, right? Do nothing by hand. Make sure that you have to, when I say do nothing by hand, none of the multiplication by hand. I'll show you exactly what's going on. It says solve 4w squared plus 12w minus 44 algebraically, and that, by the way, is using the quadratic formula as one of the algebraic methods for w to the nearest hundredth. So that means you have to go all the way down to rounding, right? So let's go ahead. So a, the first thing that you do, I'm just going to put it over here. A equals 4. This is A. This is my B. B equals 12. This is my C. C equals negative 44. I'm going to go all the way over here, and I'm going to put X equals negative B, which is negative 12. I'm going to erase this A. It's bothering me. All right, plus or minus. How do I have? Square root. I'm getting it from here. B squared, which is 12 squared. Put it in parentheses. If it's negative, you better put it in parentheses, all right? Because then it'll be messed up. Minus 4 times A is 4, times C, which is negative 44. Close parentheses. I'm going to extend this out, and I'm going to put this whole big line here. Division. 2 times A is 2 times 4. So I substituted everything in. This is what I mean by hand, right? Don't do it by hand. I'm going to clear this out, and I am going to go, and I'm going to put 12 squared minus 4 times 4 times negative 44. So just make sure, you see this 12 squared, I know it's positive, so I don't need parentheses, but if it's negative, you better put the parentheses around. All right, so if I press enter, it's 848. Did I do any of this by hand? No. So it is 848, so I'm going to rewrite x equals negative 12 plus or minus square root of 848 divided by 8. So I'm going to split this up. See this plus minus? So I'm going to have x equals negative 12 plus square root of 848 over 8. Then I'm going to have on this side x equals negative 12 minus square root of 848 divided by 8. Grab your calculator. So I put negative 12 plus square root of 848 over 8 in the calculator. I'm going to press enter, and I'm going to get my first root, which is 2.14. All right, so x equals 2.14. Round it to the nearest hundredth. Just let me check to see. Yes. So this is 1 root. Then I'm going to go over here. I'm going to put this in, and alpha x gives you the little fractions there, so you could put that easily in to the calculator. So it's negative 12 minus, now square root of 848. Am I doing any of this by hand? Absolutely not. Enter. It is negative 5.14. That is it. You are finished. It is finished. Done. Do not do anything by hand. I've seen a lot of people try this, like 12 squared, 144, minus this and that. No, put it in the calculator without the square root, All right, and just rewrite your steps. All right, and that's it. Even this, there's nobody that needs to know what this is equal to except for these two things. This is what it's equal to, and this is what it's equal to. All right, that's it. There's not much work there. All right, quadratic formula. All right, just make sure you're looking at the, that guide in the back, the reference sheet. Make sure you have that. All right, it's a good question. All right, so number 24, you probably be asked to solve or graph a system of equalities of a linear system. The question might ask you to graph one linear function and one quadratic. The intersecting points can be found on the calculator, on the coordinate grid. Just remember what you know about extending the window on your calculator. If you do not know how to extend the window, please watch my videos on extending the windows of the calculator. They're in the video section. Press window and change the values for the x and y axis as needed. To return to a 10 by 10 graph, always return to a 10 by 10 graph by doing this. You just press zoom and you see this standard, it'll return to a 10 by 10 graph. All right, so that's it. Here we go. For for June 21, number 35, you have to graph these inequalities. So let me just go over these things right here. Switch the inequality symbol when dividing or multiplying by a negative. We told you that. A solid line represents the less than or equal to or greater than or equal to, and a dotted line represents a less than or greater than. The double shaded area should be labeled with a giant S. That is the shaded area of the whole system. All right, a point in that double shaded area means that it's a solution to the system because it satisfies both inequalities. All right, so here we go. Let's go ahead with that first one. It is in Y is less than or equal to negative 3 over 4x plus 5. So remember, we could just go ahead and put this into the calculator right away. We're going to have the y equals, and we're going to clear that. And I'm going to go to the utmost, like the left. You see where it's blinking there? And I'm going to change that to a less than or equal to. All right? You can't change it to an or equal to, but you could change it to a less than. If I press enter, this will come up. If you press enter, and then you go down to line and you press to the right once, that is greater than. I need less than. And then you press to the right again, and you see how it's pointing down a little bit. That is the less than. Then you go down to OK, you press enter, and you'll notice that it is there on this, in this Y1, and then just go over to the right of the equal sign and just put in whatever you need to put in. So this is negative 3 over 4, so I'm going to press alpha x, and I'm going to put negative 3 and over 4. I'm going to press to the right, and I'm going to put x. And I can't see the rest of it. So it's plus 5. And I'm going to graph it. That is my graph. That is what I have to actually graph there on the coordinate grid. So I'm going to press second function and graph. I'm going to go back to negative 7, negative 8, 11. I can't fit that because I know it's a 10 by 10 graph, so I'm going to go to negative 4, 8. So negative 4, 8 is the first thing that I am going to graph. So negative 4, 8 is on my graph. I'm going to look for a whole number coordinate is, my next whole number coordinate is 0, 5. 1, 2, 3, 4, 5. And here's my point. And I'm going to look for another whole number coordinate is 4, 2. So 4 over and 2 up. I'm going to get another one on here. Let's see if I can. It is 8, negative 1. So 8 is right here and negative 1 is here. And that is basically it. All right. So I am going to go ahead, and this is an or equal to. So this is a solid line. Oh, yes. Solid. Right? So I'm going to grab the ruler and I am going to go ahead and make sure that I have arrows. I'm going to label that line y is less than or equal to negative 3 over 4x plus 5. All right. I am going to make sure in my calculator where I'm going to graph it's less than, so that means it is shaded down. Okay, so that is shaded down. And then the next one. The next one is not in that y is not solved for y, and we need to do that. So I am just going to go ahead and subtract 3x on both sides. This cancels. You have negative 2x, negative 2y is greater than negative 3x. I put the negative 3x first, plus 4. Then I'm going to divide by a negative. Once I divide by a negative, I'm going to flip that inequality symbol. And negative 3 divided by negative 2 is positive 3 over positive 2. And it's x. 4 divided by negative 2 is minus 2. This is what I have to graph on my calculator. I'm going to put that in 3 over 2 x minus 2. And we're going to put it in as y2. So alpha x, it is 3 over 2x. That is a positive minus 2. Now this is a less than symbol. If you can see it, see that less than symbol? So that means I have to put a less than symbol here as well. So, or else I'm not going to see what the shading is. So I'm going to press enter and I'm going to go to less than. So I'm going to press 2 times to the right and that's the less than. I'm going to go down to OK, press enter, and I'm going to graph. Look at my line. Do you see the double shaded area? So I'm going to press second function table and I am going to go all the way up to negative. See negative 4, negative 8, negative 6, negative 11. I'm going from x to y2. I cannot fit that. I'm going to go down to negative 4, negative 8, and I am going to graph that in red. So negative 4, 1, 2, 3, 4. Negative 8 is all the way down here. All right, this is a positive slope. Negative 2, negative 5. Negative 2, negative 5, 1, 2, 3, 4, 5. So this should be going up from left to right, and it is. I could tell just from the first 2 points, and 0, negative 2 is right there. 2, comma 1 is right here. 4, 4. Right there. And I could tell I'm rising 3, running 2. Rising 3, running 2. Rising 3, running 2. So let me get this out of the way here. This is not a solid line. This is a dotted line. Right? It is dotted because it is not or equal to. So I am going to graph that with a dotted line. All right, so let me move this over just a little bit. And I am going to put y is less than 3 over 2, x minus 2. So just because I want to check, I want to look at the graph, and you see that red? It's below. Then I'm gonna shade. So that means everything below of this line, I am going to shade in and create that double shaded area. So I'm going to go this way. And you could see my double shaded area. Hopefully. Okay. So you see my double shaded area, and look what I'm going to do for my double shaded area. And hopefully it does show up nice. There's a giant S. Double shaded area. Right? So here we go. It'll always ask, I'm surprised that, you know, if it didn't ask, like, what, will it, is there a point that satisfies the, that solution? If they say it's like, say, 0, 2, it will satisfy the solution. 0, 2 won't satisfy the solution because 0, 2 is right here. And that means it will not satisfy the solution. It's not in the double shaded area. All right. And just be aware of that. And that is it. All right. All right. Let's go and get this going. So, number 25, you'll probably be asked to identify coordinates that are equal or not equal for the two different functions. Values that are equal mean that two functions intersect at a point. Values that are not equal, they are not intersecting at a given value. So just remember, we're looking at the values right here. We're looking at values right here, right here, right here, and those are equal. So which value of x, x only, are they not equal? So x, okay, so x is, this is -2, and they're equal at -2, so that's out. This is x as -1, that's out. This is x at 2, they're equal right there, that's out. At 3, they're not equal, that's it. All right, so just be aware of the questioning right there. All right, so I'm just going to, done with all the questions here. So we're just going to ask, let me just get back to that. Okay, so just going to look at some of the questioning here where it says that, hey, here are some of the functions, is linear, absolute value. This is what a linear function looks like. It's a straight line. An absolute value is the, a V shape right there. A U shape is a quadratic, and a square root is that right there. So, if you're asked about the transformation, we know that any parent function is x squared. This is the parent function. Anything x plus 7 moves to the left 7. All right, even though it says plus 7, inside parentheses is opposite. Remember, kind of like the vertex is happening. X minus 5 squared moves to the right 5 from the parent. And that's it. Commutative property. These are all the properties that you have to, kind of remember. Big commutative property, big question on this is always distributive property of multiplication over subtraction or addition. Just be aware of that. Addition property of equality. Remember, you're adding 3x to both sides, and that's what makes it the addition property of equality. If you're subtracting on both sides, just remember it's the subtraction property of equality. The only other thing that I'm gonna put down here is that, as I'm remembering, is the difference of squares. We did it already. If you have x squared minus 49, just make sure that you realize that that is x plus 7, x minus 7. All right, little tips and tricks. That middle term with the x is canceled out, so that's the reason why it is it's the x plus 7 and x minus 7. Remember, it's the difference of squares and a perfect square. Good luck, everybody, and study up everything on here in this video. I hope it helped you. And, you know, good luck. Use your calculator. Make sure it's all charged and everything. And remember what we said about all of this stuff. Just put it in the calculator. If you don't know how to do something, just put it in the calculator. If they're asking for an equivalent equation or anything that's equivalent to another, put it in the calculator, match up the graphs. That's it. All right. And good luck. Thank you for watching. Thanks, everybody. All right.